Hey, in this lesson, I'm going to show you how to solve systems of two equations 3 different ways. Those 3 different ways are by graphing, substitution, and elimination. Long story short, you can kind of choose whatever method you want to use based on the information given to you. So depending on what's given to you, you might choose one over the other. It kind of comes down to personal preference. But it just depends. So like in this first example, we have graphing and we're going to solve this system by graphing. So to solve by graphing, we look for where the lines intersect and we state the point as our solution. So we're looking to see where these lines cross. And even when we solve these algebraically, we're still looking for that point. So graphically, you just see it on the graph, and then algebraically, we're manipulating equations to solve it using algebra. So we have 2 lines here, f of x and g of x. We have 1/3 x plus 5 and negative 2/3 x plus 8. So we're just going to graph each one. And if you're graphing by hand, you want to make sure and use a ruler, or you can, let me see if I can find a piece of paper. You can flip your paper up and use it as a straight edge. That works pretty good, but you want to make sure that it is as straight as possible so that you get the correct point where they intersect. So 1/3 x plus 5 means I'm having a y-intercept at 5. Let me make this bigger. And a slope of 1/3. So that means it goes up 1 over 3. This graph is kind of hard to read, but hopefully I got that. And then draw your line. Mine's a little bit off. Let's try that again. That's a little better. That is, oh no. What happened? Oh, sad. I don't know why that happened. That's 1/3 x plus 5. Now I'm going to do the other one. It was negative 2/3 x plus 8. So I have a y-intercept of 8. Then I'm going to go down 2 over 3. Am I losing it? There we go. I don't know why it keeps doing that. It's glitching out. Oof. We got to try that again. I can see graphing is not my strong suit. Still didn't get it. Let's see if I can adjust it. There we go. Well, I got it. I got it 10 years later. Okay, that's the second line. Y equals negative 2/3 x plus 8. And we could see after 10 years of me trying to graph this that it intersects there at a point. It looks like 4, 6. Nope. 3, 6. Sorry about that. 3, 6 is where our 2 lines cross. So what that means is that if I were to plug in 3, 6 to both equations, it would come out to be a true statement. So if I were to plug it into the first equation, I get 1, nope, I'm so sorry. I get 6 equals 1 plus 5, which is true. And then in the second equation, plug it in, I get 6 equals negative 2 plus 8, which is also true. So since it fits both equations, it is indeed the solution to the system. So it has to fit both. It can't only fit one. And that's just kind of confirming it since I graphed by hand and obviously have trouble graphing. I wanted to just check and make sure that I got the right point, and I did. So we're good. So that is our solution. That's it. So that's how you do it by graphing. If you're doing graphing and it's not in y equals like it is for this example. So let's say it had been -1/3 x plus y equals 5, and I want to graph it, then you just isolate y by adding 1/3 x to the other side, and then you can graph it. So that's just one simple step if you prefer to graph. Fix this. I do not often prefer to graph. So that leads me to substitution, which I like better than graphing. Substitution is the most efficient when one variable is already isolated. So, like in this example below, we have -1/3 x plus y equals 5, and we have y equals -2/3 x plus 8. You might kind of recognize this system, so you might know the answer. If not, then keep following. So y is already isolated in this second equation. So that means that I can substitute what y is into the first equation. So I'm going to take that and I'm going to sub it in. That means replace y for what it equals. And then I'm going to simplify where I can. I can add these like terms. I'm going to reduce that. I'm going to isolate x by subtracting 8, divide by -1, and I get 3. But my answer should be a point. I only have the x coordinate. So now I need to use the x coordinate to find the y value. Now, at this point in this problem, you can use either equation, either one of these. I'm going to use the second equation because y is already isolated. Y is -2/3 x plus 8. I found x to be 3. I'm going to simplify, and I get 6. So my solution is 3, 6. So these are lines. Well, that'll work. I meant to box that, but that's okay. These are lines, and they're not both in y equals form, but I could easily get them that way. And I'm saying that these two lines have the same point. They intersect at 3, 6. So I want to pull something up really quick before I go into the next one. I'm going to go to y equals, I'm going to type in, I'm going to go up here, rewind. I'm going to go to 1/3 x plus 5. And then I'm going to type in -2/3 x plus 8. I'm going to go to the table. And if we look at this table, the green, the y1 is that first line that I typed in, and the y2, the red one, is the second line that I typed in. And then the far left, the x values, those are just x. So in the first line, you can see, or the table, you can see at 0, one line is 5, one line is 8. At 1, one line is 5.3, one is 7.3, and so on. But at 3, you can see that the y values are the same. They both have the 0.36 in common. And so that's just what we're trying to find. And we found it when we graphed their, how do you do that? I can't remember. No, I can find that, but I can't remember how. There it is. Graphically, and then algebraically by substitution, we did a little solving. Last method is elimination. And this method is the most efficient when both variables are on the same side of the equation in both equations, or they can easily be put that way. And then you're going to multiply one or both of the equations by a factor to make it eliminate. So that's a lot of words, but it's not that hard. This is actually my favorite method. It's my preferred method. So I use this one more than any of the others. I feel like it's the most straightforward. You may disagree, totally fine, but that's how I feel. So for this system, again, you might recognize some of the numbers. I have both variables on the same side of the equal sign. And in this case, elimination is going to be ideal. But if I were to add these two equations together, I would get a third x plus 2y equals 13. Not very helpful. But if I were to, say, multiply this whole equation by -1, the whole equation. If I do it to the whole equation, then that's okay. It's fair game. It's still balanced. Then this becomes -1/3 x plus y equals 5, -2/3 x minus y equals -8. Now, if I add the two equations, then I have -3/3 x. Y minus y is 0, so it eliminates. 5 minus 8 is -3. Reduce this, divide by -1, and I get 3. Now I can use that to find the y value, and I can use either equation. I'm just going to use the top equation, plus x, not plus, I messed that up. Struggling. Times, oh my gosh, I did it again. X is 3. So I'm substituting 3 for x. Oh my goodness. Plus y equals 5. Then simplify, add 1 to both sides. We get 6. So my answer is, again, 3, 6, which means that this system solved 3 different ways. We got the same exact answer, and it's always going to be that way. So that just goes to show that you can pick whatever method you want and solve that way, and you're going to get the same answer as if you had chosen substitution and I chose elimination, we're going to get the same answer. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.